All right, Math 8 students, this is the guided practice for 11.3. We went over one of these in class earlier this week, but I wanted to give you this walkthrough in case you need a little bit more examples of how to work through these type of questions that we've been doing in 11.3. So first of all, number 1 is asking us to explain whether the triangles are similar. And if we remember that similar means that they have the same shape, but not necessarily the same size. And what indicates shape is our angle measures. So they have to have at least two angles that are congruent between two different triangles, or more. It could be more than two triangles, but in our case, we're just usually looking at two. So we're going to label the angle measures in the figure. So first thing we need to do is figure out our missing angle measures. So we need to figure out this missing angle measure here and this missing angle measure here. And we're looking for two congruent corresponding angles. So what we need to do to find these missing angle measures is use our triangle sum theorem, which says that all three angles added together are 180 degrees. So we can take the two that we know of our first triangle, triangle ABC, and we have 41 plus 30, and that is 71, and then we're going to subtract that from 180 because that is the sum of all three angles together. So we have 109 degrees. So we don't actually even need to continue solving for this missing angle in triangle DEC because, DEF, because we have two corresponding angles already. So this missing angle measure has to be 41. So what we're going to do is we're just going to go ahead and my degree symbol there. Write those into our blanks here. Triangle ABC has angle measures. We're just going to list our angles: 41 degrees, 109 degrees, and 30 degrees. And triangle DEF has angle measures: 41 degrees, 109 degrees, and 30 degrees. Because blank in one triangle are congruent to blank in another triangle, the triangles are blank. So because angle measures, and I'm going to use my little angle symbol, in one triangle are congruent to angle measures. In the other triangle, the triangles are similar. And we're not putting congruent because we don't know if they're the same size, because that has to do with side length, but we do know that they are the same shape because that has to do with angle measure. Okay, so we're going to go ahead and move into the next one here. Number 2, a flagpole casts a shadow that is 23.5 feet long. At the same time of day, Miss Gilbert, who is 5.5 feet tall, casts a shadow that is 7.5 feet long. How tall in feet is the flagpole? Round your answer to the nearest tenth. So what we have is we've got our large triangle here, and we've got our small triangle here. And so if you remember what we did in class together, what we're going to do is we're going to set a ratio where we have our small triangle and our big triangle height. Okay, and I just used a little triangle and a big triangle here. So I'm going to set my height equal to my height of my small triangle equal to my height of my big triangle, my base of my small triangle equal to my base of my big triangle. Okay, and that's going to let me solve for my unknown. So what I'm going to do is I'm going to fill in my variables with the proportion that I've already got set up here. So they've got the height of the small triangle set equal to the height of the large triangle, and putting that over the base of the small triangle and the base of the large triangle. So we're going to plug in the base of our small triangle, which is 7.5, and the base of our large triangle, which is that total length, right, which is that 23.5 feet. And then what we're going to do is we are going to cross multiply. So I'm going to go ahead and move this over just a little bit so I have some space. And then we're going to we'll have 5.5 times 23.5. And we're going to set that equal to 7.5 times h. Okay, so now that we've got that set up, we're going to go ahead and solve for h. So 5.5 times 23.5 is equals let's get my pen here. 129.25, and then that's equal to 7.5 times h. So now we're going to go ahead and divide by 7.5. Divide by 7.5. That cancels those out there, and 129.25 divided by 7.5 is 17.2. It's actually 17.23 repeating, but the question asks us to round to the nearest tenth, so that would be rounding to this place value right here. So 17.2 feet. So we'll go ahead and just write that in here. Okay, and then moving on to this last one here, we actually did this together in class, so I guess it's not the last one. We got 3 and 4. And so what we need to do here is we're going to look at our transversals. So we have 2 transversals intersecting 2 parallel lines as shown, and we need to explain whether triangle ABC and triangle DEC are similar or not. So first thing we want to look at is, we know they're parallel lines because we can see that we've got these nice little parallel line symbols. And so that lets us understand a couple things. So let's use a couple rules that we know from our previous modules. So if I look at this transversal right here and these parallel lines, I can know that from my parallel lines and transversals that this angle right here and this angle right here are alternate interior angles. And when you have alternate interior angles with 2 parallel lines, they are congruent. So those 2 are the same angle measure. They are going to be the same angle measure. So then I have this transversal here, and I have the same thing that I can use. I've got an alternate interior angle pair, and so I know that those 2 angles are congruent, which means that I have 2 pairs of congruent angles. So I can go ahead and fill this in now. Angle BAC is congruent with EDC, since they are, what did we call them? Alternate interior angles. So they are congruent, and I'm going to use my congruent symbol here. Alternate interior angles. Okay? And then I also know that angle ABC, this angle right here, and CED, this angle right here, are also congruent because they are alternate interior angles. So also congruent, they are alternate interior angles. And by angle-angle similarity, so we're going to go ahead and put angle-angle similarity. And yes, I just have to write over that. Triangle ABC and triangle DEC are similar because they have 2 corresponding pairs of congruent angles. All right, and this last question we're looking at is our essential question. How can you determine when 2 angles are similar? Well, first thing we need to do is determine if 2 angles are congruent, if we have 2 pairs of corresponding congruent angles. And then if they are, then we have similar triangles based on our angle-angle similarity postulate. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then by angle, angle, similarity, I think I spelled that right, the triangles are similar. Okay, and so that's it for the guided practice. I hope that gave you guys a little bit of a little extra walkthrough and some examples for 11.3. If you have questions, please bring them to class. Please make sure you're asking, and I will see you on the flip side.